and advanced engineering, and in various international conferences conducted at places like SIT Tumkur, NIT Hamirpur. His work includes optimization of energy consumption in DXAC using MATLAB Simulink for improving performance and thermal comfort, energy efficiency in green building, India concept, energy scenario and energy efficiency program and policies of booming India, and many more. Received rupees 6 lakh from AICTE Modrop, New Delhi, India for project on computerized multi-point fuel injection system for performance evaluation. He was a principal coordinator, completed a industry-based project to design and develop a robot arm for upcoming apparel industry in NCR, New Delhi. It is a pleasure to welcome you, sir. Kindly take over the session.
First of all, thank you, Suresh Kumar, for introducing me.
Thank you, sir.
And before I go, I will get a quick note of I thank Dr. Basraj for having invited me here. You are the principal of Coorg Institute of Technology. Thank you very much.
Welcome.
Yeah. Before I think we can start the session and go ahead with that.
Sir.
Yeah, sure.
Now you can share, sir.
Yeah, that's what, because it wasn't there. Okay, I'll do it now. All right. 1 minute. Is it visible now? All right.
Yes, sir. Yes, sir.
Yes, sir.
Okay.
It's starting.
Okay, that's fine. That's fine. One minute. I'll just. Because I'm not used to this Zoom, no, that's a problem there. I'll anyhow, I'll take care of that. All right.
No, sir. Just you click on that presentation mode.
Because there is
At
a
the
bar.
bottom, right bottom, sir.
No,
right?
no, that I know it, but that is being. I'm not going to get this. There's a bar coming out. I'll just check it up if there is a problem. 1 minute. Okay, I think I should be able to do it now. I think it's good.
Yes, sir. It's clear. Clear.
Fine. Thank you. Good afternoon, everybody. This is Ramesh from Presidency University. So the present topic is the role of mechatronics in industrial automation. So here in this session, I'll be talking about basically a bit of mechatronics, automation, and how these mechatronics and industrial automations are bringing change in the current scenario there. This is what I'm going to talk about now here afterwards. As you know, we're all surrounded by various gadgets. Could be these could be mechanical gadgets. In most of the cases, we basically are surrounded by the systems which are integrated with various other technology or disciplines there. So this is what basically brings us here on this platform, mechatronics here. Now, during before 1970, whatever we see today were not existing. They're all mechanical oriented one. So mechanical oriented means we talk about the movement, the physical movement there, right? So everything was done on the terms of mechanical there. But later on, people have realized that mechanical systems have their own deficiencies. Maybe in terms of the efficiency is very low there, or it could be in terms of the drop in the performance there, what is expected as per the design standards there. So keeping all those things, and people realize that we need to do something for this. And this was done by, in 1969, an engineer from Japan industry. He has developed this particular platform, Mechatronics. I call it as a platform, although he has devised this mechatronic word himself. So this mechatronic word has become a platform for everybody, especially people who would like to efficiency, performance, and the quality of life. So this was the contribution from by that particular person there. So as we go further, so these are the few things which I'm going to talk about. As I told you earlier, mechatronics I'll be talking about. Automation. Then I'll be combining this mechatronics and automation, how it will be helpful in the future there. So this is what basically your mechatronics looks like there. As I told you earlier, so it was in 1969 this word was coined, and it has become a platform here. So this basically mechatronics, as everybody knows, it is nothing new here. So it is basically not merely bringing different disciplines together here, because any systems you talk about, right from your home or this kitchen appliances and till the space aircraft, everywhere you will come across that the systems what we are using or the devices what we are using, they are not designed by an individual, or they are not controlled by a particular discipline. Gone are the days where we talk about only mechanical or only electrical or electronics. It is now a platform which has helped everybody to come together so that you will be able to devise certain systems which are helpful for the human being or for the society as a whole there. So that's why we call it as it is a synergetic integration. See, when we say the word synergetic, it has its own meaning. It is not, he would have said it, mechatronics is only an integration of various elements what we have written over here. It is the synergetic integration. So synergistic here refers to when you combine 1 plus 1, so it becomes 2 mathematically. But in many things, it talks about the performance. The performance of one when you add up with the second one, so the performance, overall performance should go up. It is something like it is a joke on the day saying my half knowledge and your half knowledge put together will not give you a full knowledge. Many a times it is a quarter knowledge, but unfortunately or fortunately, as far as the mechatronics is concerned, it is a perfect integration wherein the combination of various disciplines will help you to bring out the best. So that's where you come across this mechatronics here. So this is, as I told you earlier, when you are talking about different disciplines, it is basically from the disciplines you are going to get different system there individually. It could be a sensor, actuator, signal conditioning, power electronics, decision and control algorithms. So it means to say, if you look at these terminologies, you can think of that it is basically a combination or an integration of different disciplines along with the mechanical things. Whatever we have been doing so far by using the mechanical designs, now we are able to improve the performance of that, the efficiency of that, reduce the waste, or also reduce the intervention of human being. So in that case, you use various disciplines: electrical, electronics, computer science, control engineering. So these are the few systems which, when integrated together to bring out the best in the mechanical design, so then it emerges the mechatronics. And this is roughly called as a system engineering, because in the case of a system engineering, we normally bring out all the platform. On the platform, we bring out the different disciplines, the different technology on the same platform, so that you'll be able to devise the same thing there. Now, as you go further, especially this mechatronics has certain foundations, and this foundation is basically based foundation there. You can see that these are the various technologies, or you can see the disciplines, you can call it. So it is a synergetic integration of information system, a computer system, electrical system, mechanical system, and also in the computer science, you always talk about electronics also part of it. So when that is the case, this integration of various technology disciplines will be able to help to devise certain devices which are going to make a mark in the human history there. So far, we already seen various things like right from the beginning, as I told you earlier, even if you look at a small a mixie in a home, right, or a toaster, and then you can go to a normal chopping machine, a vegetable chopping machine, auto chopping machine there, or it could be a egg beater, or more precisely you can call it as even in your fully automated washing machine. All these are not independently made by mechanical alone. It is always a combination of our different disciplines have put their hands together or joined their hands together to see that a particular product works very efficiently. If you look at 20 years back, what washing machines you have seen are entirely different from today. Today is the case wherein the various technologies like fuzzy logic based washing machines are coming up, have already come up. So these fuzzy logic means basically you try to fine tune the performance and give the best to the society. So with that idea only, all these disciplinary foundations have come together on this platform, Mechatronics here. Now this is not really into integration, as I told you earlier. You got basically a multidisciplinary, cross-disciplinary, and interdisciplinary. These are the words which makes your mechatronics as a synergetic integration of various things there. What you see here is when you say multidisciplinary, so bringing multidiscipline together, that's a physical thing. But cross-disciplinary is basically you will be evaluating from the perspective of another discipline. It means from the point of other discipline, like especially in terms of the performance. So you'll be able to see that how really this electronics will be able to help you, the mechanical device, to do its job very efficiently there. So from that perspective of a particular discipline, this cross-disciplinary basically does. And the interdisciplinary, as I told you earlier, this is an integrative process involving more disciplines simultaneously to bear on a problem. So here, interdisciplinary basically works on simultaneous working. You're not really talking about only particular discipline talking in one corner. It means to say, what I am trying to tell here is, it is basically the not working in isolation, because nowadays it is basically teamwork. Whenever you go to any company, they look in basically your personality test. In that case, they look at whether you are a team leader today, because nobody can work in isolation. So similarly here, interdisciplinary means you have to bring in the various technology, and there must be a proper interaction between these disciplines so that you will be able to get the best out of it. Now again, this, as I told you earlier, it is a replacement of mechanics with electronics, right? That's what mechanics basically deals with your mechanical engineering and all the mechanical products which you see. And if you fuse them with the electronics or enhance the mechanics with electronics, that's what basically does this, right? So in the case of your microelectronics, where sensor technology plays a vital role, here I should tell you the present car, right? I'm talking about the high-end cars. And these high-end cars are, there are two varieties of cars. One is your internal combustion engine based cars, and the other end you have got the booming electric vehicles, right? All these vehicles are basically, especially I'm talking about the high-end one, they run on sensor technology there are about 60 to 100 sensors you'll be able to find. Why so many sensors are there? These sensors basically make the working of that particular, the performance of that particular vehicle so high, it will take to the new level of precision and reliability. Anything you add technology, what you look for is basically the precision and the reliability. Precision is basically, as you know, by definition, it is the repeatability of the process, or basically the measuring process, On the other hand, reliability is when you say something is given to you, you expect that should work accordingly as for the warranty or whatever the basics it has been designed with. So for example, as I told you, maybe the automobiles or mechanical fuel injection systems are a few examples which I'm going to talk about a little later there, right? So the mechanical fuel injection system what you were seeing earlier, they are only the conventional system, maybe a pump, right? So they have been replaced with the electronic fuel injection system. Nowadays you don't find this carburetor, right? So gone are the days where carburetors were used earlier, right? So they have their own limitations as far as any mechanical system, because a carburetor is basically a mechanical system. Everything works on the mechanical components, right? So in that case, in order to enhance the performance of that, this mechatronics has uh, played a vital role here. So these microelectronics is one thing which we need to say, that there are various elements which will come into picture there, so that we'll see that. So basically idea is any advancement, any integration of technology will help only make the life more efficient. And so also with the automobiles here, they make it more efficient and less pollutant. That is what the basic trend is. Now the question is, why mechatronics? Why should you go for this, right? So as it's very clear, one is whatever we had seen earlier in the mechanical system, they are less efficient, right? Because of the inertia, because of the various parts are involved there. All mechanical things are there, means movement. So movement is always resulted in friction, right? And resulted in inertia. So that will hinder the performance of that particular system. So in the initial state, we started with this mechanical system, but later on we try to integrate them so that we'll be able to improve the performance there. So in that case, one thing is you'll be able to reduce the cost of production also there. How we will be able to reduce the cost of production as we go further, we'll be able to use that. Like for example, when you want to talk about this reduce cost of production, so the conventional production methods have gone, right? Nowadays, you don't find, especially in advanced countries, especially the developed countries, you don't find people working there, right? They're all autonomous factories. You don't find people working there. All humans have been replaced by robots, which is one of the best examples of mechatronics. And also, as I told you earlier, basically to achieve, why mechatronics is to achieve accuracy and precision. And one more the thing is that I must be able to control, means any system designed by me should have a control. I must have exercise the control there. Then apart from that, everything is focused. All these the achievements which you are looking for, basically for selling the goods, selling the product. If you are able to satisfy the product, satisfy the customer through what you deliver to him, so that that product will be able to give him the best comfort service, then your job is done. Your job is done means that everybody has really succeeded, whether it is the industry, engineer, anybody who has designed that. So finally, he has succeeded it. So it means to say, you can see that there is a lower power on the other side, multiple tasks. That is another thing. Multitasking is the great thing one has to accept this, which is normally not done by human being. Although people nowadays, especially younger generations, they go for multitasking quite comfortably, but what is the efficiency, right? So that is what this mechatronics will give you, the capability of multitasking by a system there. Then easy to use and control. That's what I told you. Accuracy, complex, all those are the questions which can be really be answered by this mechatronic system. Few examples, as I told you earlier, this is one thing. As for automobile there. Automobile has got, as I told you, there are about 60 to 100 being used. So once you talk about sensors, you find that these are basically devices for sensors, sensing the things, right? Either from distance or from touch. So there are various things. These sensors can be either temperature sensors, humidity sensors, right? Or it could be fuel sensors, right? Or it can be for various other reasons there. Or the most important thing here, what I'm talking about here is basically the ABS, right? So ABS is one thing. Another one is especially in the cars, what you see here is airbag system. ABS is basically airbag system. Another one is your anti-lock braking system. These are the real the boon to the automobile industry there, especially the airbags. Now with the introduction of the new norm by the Ministry of Transportation, they said that by another 2025, all your cars manufactured or rolled out of the industry must have these airbags, right? And they must have the certification of crash test, right? So these are connected things there, right? So when you have so much applications widely accepted here, then obviously mechatronics make inroad into all these areas. There are many more things there, but as of now I am talking about a few things. As I told you, it can be a brake by wire system, steer by wire, integrated vehicle dynamics there. With the introduction of autonomous vehicles which are coming up now, right? Autonomous vehicles are vehicles where you don't find it is something like a driverless cars. When you have driverless class, the complexity increases. Not only it is limited to the mechatronics, it goes well beyond that. So that takes a what is known as industry 4.0, that I may touch or I may not touch at the end of the topic here, right? So these are the things, these are the various features you need to look at that, especially from the point of safety, performance, and precision. Because here in automobiles, safety is also one of the things. Here ABS is one thing, it is basically for the safety, especially when a crash against any wall or any accident happens, then you are the first one to hit. So the first two drivers, I mean the driver and the next one, so you must be able to take care of that load. So that is done by ABS there. On the other, anti-lock braking system is one, wherein anti-lock braking system, most of you know it, there is nothing new here. As far as anti-lock braking system is concerned, there, when you are driving a two-wheeler or a four-wheeler at a high speed, you suddenly apply brake. What you get first, what you get is you will get a shock, correct? Whole body, including your vehicle, gets the shock. So if you are able to sustain, if your vehicle is able to sustain the shock, the impact, then your vehicle will be stable even when it's put the brake. But in most of the cases, you don't find that especially when you put a brake, no question of you holding the wheels perfectly well. There is always some kind of a tumbling. So in order to avoid this, what they have come out with is anti-lock braking system. So here, in the case of anti-lock braking system, the sensors are connected to every wheel. So depending upon the speed of your wheel, it will apply the necessary conditions there. So that is done by, again, the various electronic system will come into picture here along with the sensors. Now, as far as this evolution of this mechatronics, how really had started, as I told you earlier, before 1970, there was nothing like that. All mechanical systems were used conveniently there. Most of the households, what you see, they relied on mechanical engineering alone for their design. But in 1980, so the boom in microprocessor, mechatronics grew more popular. It is basically, when you say microprocessor is the one wherein it is mini computer. You can feed the data and extract the data whenever it is required there. So with the introduction of this microprocessor, so things have changed. That's where the boom of mechatronics has started. You can see these are the few systems that normally see as far as mechatronics revolution is concerned there. You can see that automated factory. You don't find anybody there, right? So most of the works have been done by your automated system or robots, you can call them as. It is basically by achieving the various activities automatically by integrating one technology with the other technology. And take the case of your camera also. It is also one of the mechatronic systems, right? So the aperture, what you see, autofocus, that is one thing. Adding to that, you will find that you can see that the bottom one, what you see, especially the left one. 1 minute, I'll see that. I use my okay. So now what you see here, so this is your masterless cam, right? So generally for cam, so it is a very conventional one, but nowadays things have changed. So this is one thing. Then this is a recent one. This is home intelligent sweeping machine, which is available now for about 20 plus 1,000 rupees. You will be able to get that. And this is one thing where you see here. This is your swag, right? So this is basically for what you call as a short transportation within the campus. You will be able to use that and do it. Now, when you want to use this means what all the things you require. It has to have a lot of sensors there, motors, batteries, control shafts, right? All those things are being used in this case. This is one of the best mechatronic system, and mechatronic technology has been embedded in this case, right? Then other applications related to what is known as for medical applications. These medical applications are very, very important, right? Because they are what do you call as life-saving applications. The person who has lost his limb, you can see that how this has been taken care, right? So this is why it should be able to sense, because it is not merely putting a rod, right? It is a flexible rod. So this almost simulates that of a leg, so that the person will not feel that he is without the leg. That's what you will see that. Another one is pacemaker. The last one what you see here, this is a pacemaker, right? So pacemaker is one other one there. So here, because the very name indicates there, it will be able to pump the blood. It will help you when there is a problem with the heart there. Obviously people will go for this pacemaker when the heart cannot pump the blood with the rate expected. Then you always go for this pacemaker. It takes the place of heart. Help, in fact, although it cannot take the place of an heart there, it will help and boost the performance of that particular heart. And this is something this is from a sci-fi movie. You can see that there are no hands there, but nothing is left less than hand. What you can see that, you can see that various devices what is connected here, those are all the part of your mechatronics. You don't really see that, right? And this is another drone kind of a thing there. For example, if you want to take out if you want to carry small luggages or something like that to drop, well, these drones will be able to do that. And these drones are the best mechatronics applications there. They are being used for many things. And the other one is these are sensor based what do you call as you'll be able to get the water by putting the hands there, right? So these are the few things. In addition to that, especially for the defense purpose, there are many applications are there for defense. In the case of defense applications, especially, for example, if you want to know in advance that if there are any bombs are there on your path, so you normally send that vehicles there, right? Unmanned vehicle there. So these unmanned vehicles will go there and check in hazardous places there. So this is basically for your mechatronics contribution there. And another application is your smart home applications, right? Smart home is basically for the security purpose. If there is anything like a smoke coming somewhere in the corner there, so it should be able to sense, right? This is only one application I'm telling you, but otherwise smart home application, there are many there. Even the visions are there, right? It will be able to take care of that. Even the intruders can be checked, right? Even the voice signals can also be there. So that is where you'll find that various applications like smart home application is gaining momentum. And Philips these days has come out with this home application for lighting also there. As you enter, or even before they enter, you can see that your the lights are on, fans are on, AC is on, whatever the systems are there, right? Even your geyser is on, right? Your home automation is including all these things there, right? So in order to see more of these smart home applications, you can refer to the Google. You will be able to tell you more of the things there. There are mechatronics has got different levels as it started in 1970 there. So there are initially integrates electrical signaling with mechanical action. That is where the beginning of mechatronics has come into picture, especially to open the valve, open and close the valve through the relay switches there. That is the first primary first level of mechatronics. In the second level of this is basically an integration of electronics, as I told you earlier. So mechanical plus electronics. So you will be able to see that electromechanical systems can be made. So one of the examples is a player, right? So where by the switch of a by pressing a button, you'll be able to open and close and start the rest of the things there. Then the tertiary level or the third level of mechatronics is basically advanced control strategy of microelectronics, including microprocessor, where you'll be able to have the circuits, specified integrated circuit for specific applications. It could be a microprocessor based electrical motor, So this is very, very common, especially what you call as microprocessor based electrical motor. Electrical motor is one is to control the motor. Another point is you have that microprocessor based water level indicator is also one thing. It is not merely indicator, water level controller, more precisely there, right? Nowadays nobody will go for switching on, switch off the your pump or a motor for getting the water lifted to the your the top floor, right? It is all sensor based, so microprocessor based there. They'll be able to do that based on the levels there. So this microprocessor is already planned and programmed, and accordingly it sends the signals to the electric motor, and that motor will be, since it is connected to the pump, so the pump will start pumping the water. So that is what is generally done there. On the quarter level is the fourth level is basically it is to what you call as include the smartness, right? So what smartness you got? So smartness is because of the introduction of our new technology, especially information and technology, right? In the case of information science, you see that artificial neural network, the fuzzy logic, right? So that will help you to detect the faults, right? And isolation capability into the system. So that's where you find that various levels of mechatronics will play a major role in bringing the best right from 1970 till today. So these are the few basic elements of mechatronics system there. You can see that as so for mechatronics system, mechanical system is one where we want to introduce various other disciplines there. So it comes from digital actuators there. So one is for any these basic elements are one is the mechanical system that is connected to an actuator there. So this is actuation is the final output, and this final actuation has to be done through the integration of other technologies there. So it is one is the digital actuator there, and you got analog actuators there, then digital sensors, analog sensors, and these are all controlled by a microprocessor system for control. That's how you'll be able to integrate all these, especially the output from the mechanical system. So you'll see that digital sensor will be able to sense. This is basically from the control system there. So basically here the open control system and the closed control system. Open control system is the only thing which does not have any feedback. But whereas in the case closed control system, that is what is being used everywhere, because one has to know, one would like to know what is the output, whether my output is in line with what my requirement. If that is the case, then only you'll be able to say, okay, go ahead. Otherwise, it has to send back. So it has to send it back to the original one or the reference input, and based on the reference input, you will be able to see that if the reference input and the real output is okay, then only it says that it is fine and it can be processed. One of the examples what I was mentioning is basically the mechanical fuel injection system here, right? So this is the fuel injection system for a vehicle, especially a diesel vehicle there. You can see that there is a fuel pump there, right? So this is the conventional method of pumping the fuel into the your number of cylinders there, right? So then you can see that there's a tank, idle control valve, then the fuel pump, barrel valve, and injector lines and the injectors there, right? This is the case, this is a very conventional system there. So depending upon the requirement, the pump is right, either it will the switch it on, switch off. So that will be able to give a sensing that they should be able to pump the fuel through the injectors into the cylinder. This is what basically your mechanical injection system is there. And there are a lot of things like pressure control, all those things have been taken care through the your conventional mechanical system here. But if you look at the mechanical injection system, this basically involves a lot of hindrances, right? So there is no performance improvement there. Whatever you have set it, it will come, and there is every possibility that the things might go wrong, right? So because of inertia or anything there, so maintenance is very clumsy, and at the end of the day, you find that the fuel injection system becomes very looks very ugly there. So maintenance is another problem there. So one is the performance drop in performance followed by higher maintenance, although the cost of this is less compared to the large production. You'll find that the cost is low, but the performance is also not so good. So from that point of view, so people have moved to what is known as electronic fuel injection system there. So you can see that electronic fuel injection system is absolutely clean, right? So it basically consists of water, fuel supply, the fuel pump, fuel filter, that is where, and later on you find that you got actuators, right? So these actuators here, what you see, these are fuel injectors, the whole thing what you see here. So this is your here. So actuators, basically one is the fuel injector there, that is what you see it here. Then spark plug later on, right? Then throttle, that's what you find it there. Whereas all these things are controlled by what is known as a EC unit or electronic control unit. This which is responsible for measurement of sensors. Measurement of sensors means basically whatever the sensors measure there, maybe a pressure, maybe the timing there, all things have to take place. Why this electronic fuel injections has been accepted? For simple reason that the fuel has to be injected in milliseconds, right? It should be done in milliseconds. 360-degree rotation of that the crank or the crankshaft takes place in how many seconds there? 50 seconds, sorry, 50 milliseconds, right? So that was the speed at which everything has to be done there. So this is whatever you have done it through the mechanical system cannot respond to that, right? Although you have designed, you have the desire that this your mechanical system has to work, but unfortunately that desire and the output what you are going to obtain, so that will never match because of the response. We have got our own response time. For example, take the case of a cricket ball, right, coming from a bowler at 140 kilometers speed. So what is your response time? How much time you got? How much time? Partially, hardly a few seconds there. Within that seconds, you must be able to check the speed, check the pace, how it turns, and you must put all your muscles force so that you will hit the ball to the boundary. So in that case, response time is very, very important there. That's why not everybody can become Tendulkar, not everybody can become Virat Kohli, correct? It all depends upon your response time there. So that's why, especially at the fag end of the cricketing career of Tendulkar, he said in one of the interviews, my response time fell. So the time required to respond to the coming ball was increased very high there. He wanted more time, but ball never gave him so much time. That was the thing where he had to retire. He had to retire without doing much at the fag end there. That was one of the that response is very, very important. Human response is different. Even whatever the device you go for, devices, mechanical devices, they cannot respond to that quick speed there. So in order to avoid that, in order to achieve that quick response, so people have used these electronic system there. So because they can respond very quickly there, right? So these various sensors, when you use them, they'll be able to quickly take the data, process the data, and give the corrective actions, what to be done. And apart from that, when you say what to be done, it is finally the actuation which has to do it. For example, whatever the EC unit can do, but finally the fuel injector has to supply. So your fuel injector and the spark plug and the throttle, all these things, they must be able to respond quickly there. It means to say, when you are trying to convert any mechanical system into a mechatronic system, it is not merely connecting all your electronic gadgets. It does not help. That your actual mechanical system design has to be improved very finely. Then only your any system which you are expecting the best results will be obtained. Otherwise, it will be back to square one there. So here, what kind of sensors do you use? One is engine temperature sensor, right? Then intake temperature sensor, exhaust temperature sensor, engine speed sensor, throttle position sensor, right? So various things, sensors are, especially for sensing this, you need a probe which is responsible for the measurement of the fuel concentration in the fuel air mixture. So it means to say, at every stage of the fuel injection, electronic fuel injection system will measure every element, every parameter. Why I am emphasizing here is that whenever, if you want to be a mechatronic engineer, then in that case you need to be very good at knowing what is doing, what is it expected of, right? And what are the parameters on which each system really work. So this is your block diagram of the electronic fuel injection system. There you can see that whatever I had explained earlier, it is through the your electronics fuel injection system looks like. You can see that this is your how the information is collected from here through various sensors there. So this is the electronic this one, right, system here, right. Then you can see various temperatures are obtained by the various sensors here, and that is taken as analog inputs, right. And the engine speed is basically the what do you call as that is one sensor is there that will be able to give you, and this ECU will be able to assess the data obtained by that through the microprocessor there, right. And this will be able to give you an idea about how best your data communication and the receiving the data, right, and then how you process that becomes a vital role for you. So that's where you'll find that you'll be able to see that especially the digital output will give you the fuel injector. So that will be given to the fuel injector, and accordingly the fuel injector will be able to supply the fuel in the right quantity at the right pressure, right. Then the spark plug will be able to give you the spark, because so the spark has to come in milliseconds, right. So that should be taken care. And again, millisecond means it is not merely the function of a spark plug to give a spark. It should check the temperature, as there are various temperature there. So one take temperature, out temperature there, because otherwise what happens if the temperature of the engine is not maintained properly, then there is every possibility that this the process of combustion may not really look good. There is a knocking, right. So that's where your electronic fuel injection system plays a vital role in almost all modern cars, because your electronic fuel system has almost replaced the carburetor, wheelers, right. So they have already been replaced. But in some of the I must mention here, TVS has come up with this electronic fuel injection system in some bikes, especially the high speed bikes there, right. So that's what I happen to go through that. And you can see that there is one more thing like PC. All the data have been the sharing of the data takes place through your personal computer here. So it means to say this is completely monitored, electronic fuel injection system through the monitor, so that you'll be, if there is anything like that, one is the closed loop. That's what you see it. In most of the cases you will have a closed loop system, and this closed loop system will be able to tell you how the things are really happening there. If there is any deviation, then corrective things are already taken care there. So as told earlier, this for any of the mechatronic system, this PLC is very, very important here. So that is what you call as a programmable controller here, right. So what you see here earlier, so this data communication with this and what the data it will be able to give out, so that will all depend upon your PLC, programmable logic controllers, right. So these are basically microcontrollers there. So these are basically what you call as you can see that these systems are used in everywhere wherever you talk about mechatronic system. As I told you earlier, so many mechatronic system I gave you the examples there. In all these examples, one of the things which I told you is a washing machine. So washing machine is nowadays intelligent, really. You don't have to really worry it. So it is basically a programmable washing machine. These programmable washing machine, no, they can take up the programs. You can feed it there, whatever the program, maybe depending upon your kind of cloth, right. So what kind of cloth, whether it is a fragile cloth or your jeans or anything, you can do it, and accordingly you can fix the program, and you can fix the level of water there, and even the temperature of the water can be fixed there, and how many cycles of operation has to be done there, what is that cycle time, right. So all these things are embedded in this particular washing machine. So obviously it receives the signal, or it receives the information from you, or the commands from you, and does it in a proper sequence there. That is through what is known as the fuzzy logic system. There are many washing machines which are run on fuzzy logic system there. These fuzzy logic systems are capable of programming it and think intelligently, right. So it is when we go for this means they think intelligently and make the changes accordingly if there are any things like that, right. So with the safety installations such as airbags and sensors or anti-theft electronic keys, that is also there. Probably you can go through this anti-theft electronic keys, especially for the automobiles. So you will be able to find these are going to be especially the PLC PLC, that's why electronics engineering plays a vital role here, right? And of course, electrical engineering is another thing, whereas the computer science basically talks about the programming where, how best you will be able to program it in a proper way there, right? So this is basically what you see here. The PLC is industrial computer control system that continuously monitors, right? So it monitors what's happening there, especially the state of the input devices, and make decisions based on the custom program. A custom program is the programs which are already built in there, right, to control the state of the output device. That is exactly what you see in all these washing machines or any other things there, right? So especially of these cases, you'll find that they are extremely useful as far as the PLCs are concerned. The PLC becomes the part and parcel of your mechatronics division. Now you can see that how really this mechatronic works there. Already there. So this is only because in fact, I wanted to put it earlier, but I felt that after giving the core examples, this will be quite simple for you to know that. So you can see that there are basically the basic input power is there. Then you got the physical signal, right? So that is into, you have got electronic signal by that. And finally, you'll have to look at the actuation. Actuation is basically divided. So actuation, then mechanism there, what kind of mechanism that you are going to make use of. As I told you earlier, so any mechanism which have been used earlier, in the earlier days, and that has to be replaced. If you want to convert them into a mechatronic system, then conventional mechanisms have to be replaced. Your weight has to come down, first of all. Means you are trying to reduce the what is known as the inertia, right? Inertia has to come down. So then you will work on something like the re-engineering kind of a thing there, right? So that's what you'll see that. And there you'll find that finally your mechanical integration takes place, and see that the physical signal goes out according to your requirement. So these are basically the elements. You can see that elements like mechanical device there, then actuator, then you got electronic device, then the sensors. These are the basic elements there. And how it works means your actuator basically done on the power, what power you are going to give. Generally, it's not the mechanical power, it is basically the electrical punch which will be able to give you that. And the input is basically the physical signal there, and the electronic signal will also come there, right? So that's where you'll come across the various elements of mechatronics there. So one of the examples what I mentioned earlier, especially of this mechatronic system, is your speed control of a bike. So this is where you normally this is how you personally feel that. For example, if the vehicle has to be stopped, right? So this is how your mind works. This is how you work. So you are the controller, basically the brain, what you see here, and the actuator is your foot, how you are going to move that, right? And this is where you are going to stop the vehicle there. And here, if the distance, right, what is the disturbance there? For example, if it goes further, so then it goes back to the sensor there. It is within your brain only. So there you decide whether you must check whether what is the speed you are going with, and how much force I should apply. All those things has to be there. So it depends upon the desired speed, you can see here. So this is the input signal, correct? Or you can call it as a reference signal. So this reference signal should be always match with your output, right? So then only, or that difference, if the disturbance is 0 here, because this minus of this is equal to 0, then the vehicle will move perfectly fine. But the same thing is not true. Your vehicle speed control is concerned, as far as an individual is concerned there, because whenever you try to stop a vehicle there, it will not stop. It will still there will be some kind of a disturbance. In order to avoid that, so people have gone for this, especially for when you are running at a high speed there. So this has been taken up. So here Arduino board is used there, right? And there is an LCD supply. LCD display is basically to tell you whether that the vision is okay or not, right? So all these information is fed to the motor driver, the person who is driving this, in a short notice, right, through the display. So display means basically it is on your speedometer. So that will give you what is the current speed there, right? Whatever you see it here, all these things have been converted into here only, right? So most of the mechatronic system basically studies the what is the conventional system is being used. Only thing is they try to simplify it and automate. That's what they do it. Now, another example of this mechatronic is for automatic bone drilling. This is basically for medical application there. See, for medical application, if you want to drill a bone, right, so it is a very challenging one, right? So in that case, if something goes wrong, the bone will be broken out. So in order to avoid that, there is what is known as, when you drill a hole, what really happens is you need to control the linear movement and the rotation of the drill bit. They have to be controlled first of all, correct? So how much depth you give, at what rate you are going to pushing your drill bit, and at what speed your drill bit is rotating. So both the moments have to be controlled there, right? So this is obtained from one of the research papers there, right? So this is what is known as detection method and control algorithms are implemented here. So algorithms are basically the programs, right? So they have been programmed in such a way that there is a relationship between the linear movement and the rotation, so that your bone will not break. Number one, it will not chip out. Proper positioning of the hole has to be done, and that proper way only there, right? So that you will be able to stop the drilling procedure upon penetration of the bone, right? So this is what is generally done, especially once it is, because at the outside your rotation will be different there, but once it gets in, there are various things will occur as far as the making the hole is concerned there. So then it has to be, all those parameters has to be detected by your feedback fuzzy logic control there, right? So that will tell you based on the programming. So it will tell you whether it is matching or not. If it is matching, then it goes okay, otherwise it has to control other things there. So here, so the various logic which you have got is basically, one is the start the bone drilling, stabilization of the drilling. So stabilization means once you start drilling means there must not be any vibration, right? How do you take care of that? Then start protrusion, so you must penetrate into that, right? Then at the point of complete, that is the once it is through, or whatever the kind of hole you want there, so then you say it is over there. Although it looks very simple as far as the job is concerned, like making a hole in in the case of your bone, but it is not that simple there, because it is very precision there. You don't have a second chance, right? Take the case of when you go to a dentist, right? So he doesn't take a second chance. He should not take a second chance, otherwise you are gone, right? Because it is this dentist job is so sensitive there. He should be very, very careful. That's why he takes more time to do a smaller job, correct? Even for chipping a small few millimeter there, he takes so much time. He does it with so precision, right? So that's what is basically done by your smart electronic tool. So that device I'm going to show you here. So this is the one device what you see here. Of course, it doesn't look like the what you call as a very precision one, but it is a prototype of that. You can see that. So that's why it is basically for a experimentation purpose it was done there. You can see that the bone what they have used only a goat bone, only for experimental purpose there, right? And you got the lead screw there, what it goes here from here to here, right? And this is not a lead screw, not a, what you call as the kind of a screw what you see here, normal one. It is a ball screw arrangement is generally made there, so that the precision is very, very important. Most of the cases, these ball screw arrangements are used in CNC machines for a linear movement of the either the what you call as the table or whatever is there. So use that, and that's where you find that there's a drilling motor and the feeding motor is there, right? So you can see here there are two motors used here. One is for the tool and other is for the feeding motor. So this will feed it, right? So this will be able to move this whole of things forward, whereas this in turn will cut the hole. That's what is generally done here. Then another one is the most critical one is what is known as the diamond polishing. So diamond polishing is very, very carefully done job. If something goes wrong, that's it. You lose crores. So for that reason, so these devices which have been, of course, even if you go to the Gujarat there, you'll find that most of the people do it with utmost care, because they got decades of experience. They'll be able to do that very precisely there. But see, as I told you earlier, mechatronics basically eliminates this more precisely. It helps the people to the dependency on human being, so that you will be able to get the results even without the intervention of human being there. Results whatever 20-year guy should be able to deliver, so this mechatronic device will be able to deliver in the same time there. So in that case, and they don't really, these mechatronic systems don't debate on any work hours, and they don't ask for any pay revision or anything like that. So that is one of the advantages as far as these mechatronic system are used. So diamond polishing is the most critical one, and it is very precise one, right? And it has to be done in a very micro level. That's why you see that micro stepping motors are used here, right? And various other technology like piezoelectric elements are used there for converting this what do you call as electrical signals into mechanical signals. So mechanical signals basically actuation, that they'll be able to remove the material or the diamond in a micro level there, right? Then another one is what you see here is all your mechatronic system. What you see is basically it's a concurrent product realization. It is not something that you do one and leave the other one. It has to be done in a very sequential manner, right? So, for example, if you want to design any product by the various disciplines you got, so there is a sequence followed there. There is a protocol to be followed, right? So one is generally anything you go for mechatronics means first of all you need to have a mechanical system design, right? So design mechanical system, or you can call it as a plant design. So that is the thing what you got. And again, it is not the system, it is not the part which you are designed earlier for regular usage. It should be a different one, because when you're talking about mechatronics means you are all those parameters like the inertia, the weight, right? Adding to that, that should also be taken into account. That's why first you go with the mechanical system design there. So then you need to select the sensors, right? Proper sensors have to be selected for specific applications, followed by actuators. So various sensors, it could be a proximity sensor, or it could be touch sensor, or it could be temperature sensor, or any other sensors, depending upon the system which you are going to design. So you will have to select that sensors and accordingly the actuation. Finally, what you want is actuation. That is where the final work has to be done. That is the output of it, and mount on the plant. So you need to be very careful about selection of sensors and actuators, and where to mount. There are, for example, those who have done it already in the undergraduations, especially under this mechanical design labs, you find that to know the vibrations, or to know the vibration in different directions, you'll have to use different sensors in different directions there. So these are called as directional sensors there, right? And then you go for this design signal conditioning and product electronics. This is something has to be taken care of. This is very, very crucial. The first two is okay, but the third one is very important here. You must be able to signal conditioning and product electronics is very, very important there, right? So that is where your design principle is not about just bringing the various disciplines, but to be done more precisely then. So then adding to that, you got control algorithm. That is basically the control comes into picture there. Basically, electrical discipline has to take care of it. So using electrical and electronics microprocessor, microcontroller, or microcomputer based hardware. It means to say these hardwares which you are going to select for your applications should be able to be used by this, be connected with the microprocessor or microcontroller or microcomputers there. So they must be able to interact with that and give the information, and should be able to work in coordination with the rest of the your mechanical system there, along with the sensors and the actuators. Now, when you go for this mechatronics, so you have got this product, right? So what kind of products normally you come across this? So these products are basically what you do is, so as I told you earlier in the previous slide there, so it is a design, model, simulate, analyze, refine, prototype, validate, and deployment circle. It is basically a cyclic one, where you find that Not one is taken as the most important, but otherwise it is basically it is the process where is right from the design modeling, then simulation. So because before you really go for the final application, so simulation has to be done properly there, because you cannot fix the system and try to get the results here. It has to be done to find out whether your system really works okay or not, or your design really works or not. Then you analyze, then further refine. So these are basically the what you call as feedback system. Normally you do any of the activities there. So this is also one such, especially when you go for this mechatronic system design. So you'll have to take care of this there. So especially for the product realization, when the product is already in your mind, what is to be done there. Product in the sense your activities or the function that a product has to take care. So that should be clearly be dealt. And also in the case of your mechatronic based product realization, so mechanical, electrical, computer engineering, information systems are integrated throughout the design process so that the final product can be better than the sum of its parts. Remember this one. So this is what, if you look at this, right? So this is what you call it as the real synergistic integration. It is not integration, it is the synergistic integration, so that when you add the performance of two should give the better performance than the individual performance of the whatever you have added up. So that is what, so the synergistic integration has to be done there, right? So that is very, very important, especially when you are going for this product realization there, right? So then as I told you earlier, basically any mechatronics, you got a multidisciplinary system there, and it is not really, not only as I told you, this mechatronics is not about only a multidisciplinary approach. It is not like that, and not even electromechanical system. You bring two disciplines, electrical and mechanical, put them together. No, not even a control system. He is talking about basically that it is properly, the integration of everything has to be done in a proper manner, so that the performance what we are expecting from a particular product has to be delivered. Proper design aspects here. That's why, as I told you earlier here, so you need to see that design, model, simulate, analyze, and define, prototype, validate, and deployment circle. This has to be properly followed to see that your product, a mechatronic product, will be able to excel in the market. So this is what in connection with in the previous slide, this is the design process you need to follow that. As I told you earlier, it is basically related to the modeling and simulation there, then prototype, then deployment of life cycle. So, and this is a what you call as an iterative process, right? It is a iterative process. It is not a one-time job. You keep doing until whatever you expected it from the particular system, you need to get that. Until such time, this has to be continuously be doing that. So this is what you find out as far as the mechatronic design process. And after this, let me see that. 1 minute. You take a look at this particular video. 1 minute. This is a video which gives you an idea about how a mechatronic system should be. How do you expect it to be, right? So take a look at this. I think this is one of the best videos I saw. Well, that was a small video which give you an impetus about how mechatronics is used here, including all your sensors, actuators, and everything has been used to see that a robot has been devised there, right? So I can see the complexity that is used there, right? See, especially there are cases like how much it can extend there, right? So if you can really um, to cheat those areas, so then definitely you can really win that. So that's only from the point of video there, but otherwise that is only to show that not to win against the player here. It is basically show that the technical excellence, right? So that technical excellence has given you an idea about that how this mechatronics has helped to build this robot to such an extent there, right? Now, if you can see here, especially talking about this industrial revolution before 70 there, so it has started basically on the point of mechanical. So as I told you earlier, they're all using cams, gears, levels are there. But pure mechanical stuffers have their own problems, right? One is inability of the power amplification, right? Because there is a power loss. It could be due to the inertia or maybe the tolerances or any other friction there. So that will result in basically the performance what we are looking for. That was the restriction, the what you can call as the constraint those mechanical systems had earlier also there. And these are the systems which you can recall as mechanical systems which have been designed long ago. Of course, some of the things are still in use, but most of the things have already been replaced by your new generation system there. You can see that one is, it could be the one which you see it, especially in the say in your washroom, right? So that you'll be able to find that. And the thermostat is one where you can really, depending upon the your temperature, so it will be able to open, and that is one thing which can measure there. Then the other one is your the switches, especially cam operated switches there, right? So it can make or break the contact. That is through the profile of the cam. That is what is basically your mechanical designs are there. So then you got the governor there. This is based on basically the centrifugal force. Based on the centrifugal force, you will be able to open and close the valve of the especially depending. This is governors are generally used in IC engines there, right? To open and close the your supply of the fuel. So that is was used earlier. Nowadays, these are all replaced by the conventional one. I mean the multi-point electronic based multi-point fuel injection system there, right? So and then another one is the bimetallic strips there. Bimetallic means they'll have different conductivity there, right? So depending upon the requirement, how much it has to go there, so it will be able to refer to that. That's what you'll be able to find it in the case of your bimetallic strip. So these are the physical systems or mechanical which were predominantly used earlier there. Now the mechatronic system has come into picture basically because of the revolution in semiconductor devices there, because you have got microprocessor, you got various things there. So that led to the industrial revolution there, especially the mechatronics revolution, I should call it as, right? So one is this semiconductor device has led to this integrated circuits, right? And miniaturization, basically important thing is here miniaturization. So miniaturization means basically reducing to, yes, the size has to be reduced there basically, so that you don't have massive structures there, and you can control the massive structures in a smaller way there. That is what miniaturization there. Then adding to that, power electronics is one area which is really making grounds, right, in various areas there, especially mechatronics there. Then could amplify and deliver a needed amount of power to actuators. This power electronics, it will be able to give you whatever the power your actuator. Finally, actuator is the one which is going to deliver the power there. So in that case, it has to receive the sufficient amount of power. So it is possible only by amplifying the your power there. So those are the restrictions as far as the drawbacks of your conventional mechanical system. So with the introduction of these IC technology and the miniaturization of your power electronics there, so you found that actuators can easily work according to the needs there. Then signal conditioning. This is another area of power electronics there, right? Could filter and encode sensory data. This is basically for to make sure that your system works according to your needs there, and there are no disturbances, no losses there. So obviously you go for the signal conditioning of this. Then hardwired onboard discrete analog digital ICs are provided rudimentary computational and decision making circuits for control of mechanical devices there. Basically for all these devices are for decision making circuits there, so that you'll be able to see that the your mechanical devices are properly controlled through the actuators there. Then adding to that revolution is basically addition of or development of VLSI technology. So it led to the introduction of microprocessor, microcontroller, and so on and so forth there. So this helped us to see that the technology has come into your mechatronics to the highest level there. Adding to that, it has resulted in the overall reduction in the size, and the cost is also very low compared to the conventional system there, right? Because manufacturing technology has also developed as far as your microprocessor, microcontroller development is concerned there. So that has resulted in the cheap because automated systems are coming there to develop all these things there. Then adding to that, you got this computing hardwares are effectively in place with electromechanical. That's one thing there, right? So electromechanical system, what you see is you find that the hardwares they must be able to be connected properly there, so that you'll be able to get what you really need it, right? So then these microcontrollers are replacing precision mechanical component. That's what basically the function of these microcontrollers are. PLCs also there, right? So these mechanical components have been replaced, what you call them as very precise mechanical component. So they are replaced by these microcontrollers, which has developed into a better boom for the the designing of mechatronic system there, right? For example, precision machine camshaft that in many applications is as a timing device there. So because camshafts are basically the time what you call as camshaft is were especially used in IC engines for the timing of the valve, right? Opening and closing of the valve is done by through that only. So it has to be very precise, because as I told you earlier, the pumping of the whether it's pumping of the oil or the petrol in the your cylinder, or it could be the what you call as opening of the valves or the exhaust, right? This all depends upon the timing basically there. Even the spark plug, when to spark, when not to spark. So it is all, it happens all in milliseconds. So your precision is very, very important. And these microcontrollers have obtained that precision, or they are able to deliver that precision. With that precision, so you will be able to improve the performance of the devices there. And adding to this, these microcontrollers are programmable. That's one thing. So when they are programmable, obviously that adds to feather in the cap of the microcontrollers application there. So they are versatile and flexible alternative to the hardwired analog. So instead of going for this hardwired analog digital computational hardware, so this microcontroller can do a lot of which these hardwired digital computational hardware were doing earlier there. So that is an advantage as far as the revolution is concerned there. Then integrated computer, electrical, mechanical devices are now capable of converting, transmitting, and processing both physical energy and the virtual energy. That is, virtual energy is all your information that you are delivering to the programming there. So that is what basically is done. So with the advent of technology, all what we see today for a mechatronics, it is through the advent of technology. If better technology is available, obviously it will result in the better performance and the better product. Then these are the mechanical system elements which I used earlier, as I told you earlier. Those elements are different. These elements are basically how they can be converted. Basically, we can see that maybe a lever there, maybe a cam and follow a chain and a sprocket, right? Slider crank mechanism, lineage. So these are the basic mechanical elements. These mechanical elements earlier regularly, but nowadays these have been replaced. All the functions will remain same, but only thing is these have been replaced by mechatronic systems, so that it will be able to function properly and effectively there. That's what you normally do it. Then this is another thing, the same thing diagram what I have shown you earlier also there. This need not worry. So there are various applications as I told you, right? Right from your kitchen, right? Appliances, you can go anywhere, including defense, you can go medical implant devices, right? Even manufacturing of the robots, and machines also, right? So there are machines like SPM machines. SPM means basically the special purpose machines. The special purpose machines are generally used in automobile industry there, right? See, whole of your mechanical industry is based on your automotive industry there. That is the, if automotive industry flaps, then whole of your manufacturing activity will come down. That's what we face it today for mechanical engineers. Why the mechanics have are facing crunch as far as the job issues are concerned, it is because of this reason only. Because automobile industry is not really attained, and there is a drastic change in the automobile sector also there. Whatever that IC engines were there, so it looked for basically the mechanical factories were producing these various components and the devices there. But now this is being challenged because of the your environmental concern. Adding to that, the depletion of the oil, right, the hydrocarbon oil. So that has resulted into a greater pressure on these automotive sector. So that's why these conventional automotive sector IC engines are being replaced by your electric vehicles. Nowadays, in the last 1 week, the government of India has also announced a lot of incentives for these electric vehicles there. So when such is the case, obviously people have to shift from the conventional system to the regular system. So obviously, when you have electrical vehicles, then you need more people from different background, because whole of your electric car is an example of a mechatronic system, right? So in that case, you need more interdisciplinary people are required here, right? So that's where the application comes into picture. Adding to that, you need this automotive one is you got this anti-lock brake, active suspension, cruise control, airbags, engine management, everything is required there, right? So you find that mechatronic application is quite wide there, right? If you take the case of your electric vehicle, so in the case of electric vehicle, whole of the engine is replaced. So whatever the sensors you are using, as I told you, 60 to 100 confirmed, but not exactly so, but because there are a lot of other management has to take place, especially the what do you call as BMS will come into picture. BMS refers to the battery management system, right? So in the whole of the electric vehicle, battery is the very crucial one. It takes about at least 30% of the overall cost, and it is increasing there, right? So in that case, one has to take care about the use of mechatronics there. So then again, you got network centers distribution system there. So you got this, basically the robots are used for, you can call them as distributed robots or telerobots or intelligent highways. So this, especially telerobots, are the robots which are used in telecommunication area there. And the intelligent highways means so intelligent highways means basically the highways where the vehicles do not crash. Number one, means there is no accident. On the other hand, there will not be any congestion, means traffic will not be there, correct? So now, when you think of this, you need the service. So resources also very much required here. Not be connecting your electronic system with the mechanical system there. You need to have alternate ways, because when you say when the congestion is there, when the traffic is there, so in that case the vehicle from distance only it should be able to see that if there is a traffic, I should not use this route, there must be some alternative way, right? Alternative way. And adding to that, why normally what you see in the case of your in any of the signals, so there is a time based, right? For one direction 1 minute, another direction 1 minute, right? It was calculated long ago, and the same thing is being done, but it is not a what do you call as the correct way of doing it. Instead of that, it should have what is known as the network based. Network based means a live data should be taken based on the load, right? For a particular length of road, maybe about 250 meters or 300 meters, how many vehicles are there, right? And it has to be done lively, means every time the comes here. So just like your petrol, nowadays it has gone online. So every day this petrol rate changes. So like that, every moment this load on the the traffic load has to be measured, and accordingly signals have to be given there, so that there will not be unnecessary waiting time. So that is what basically your intelligent highways is a part of it. Then another thing is the cyber security, in the field of cyber security and telecommunications. So, and automotive engineering, robotics, all these things you'll find that the mechatronic application goes quite high. Adding to that, one more thing, the last but not the least, is the structural control, home automation. What home automation I already talked about. I'm talking about this structural control. This structure control, see, you know this in Dubai, the highest, the tallest building is the Khalifa Burj, right? So it was what do you call as it can go even in the seismic region. I mean, the earthquake occurs, it can tilt to about nearly 20 degrees, if I'm not wrong. It can tilt, means just like a tree, no, it can tilt. So how it is possible? It is not really the structure, not only the structure, structural material what has been used here. It is basically once it tilts to another one, the sensors what have been used here in all these, because in whole of the building is having number of sensors there, right? So mechatronic system has come to picture as far as these kind of buildings are concerned there. Adding to that, you got this smart irrigation system, right? So there's a drip irrigation system, integration of a drip integration system with the your automation will give you a smart integration, irrigation system there, so that it will be able to decide based on the weather condition, humidity, temperature, right? It will tell when to give water for that, right? So that the plant will not starve of water, and it will not be overburdened by the excess water there, right? So this is only the beginning of a smart irrigation system. There is what is smart farming is also there. That smart farming is quite bigger than this. The net has been increased here. So in this case, it will not only talk about the irrigate, what you call as the humidity, temperature, and enough water supplying there. It also talks about what is to be sowed, right? Which area, because it will take a aerial survey, and that is one thing. It will be able to decide where all the what is the soil condition there. Based on soil condition, it will say that this is the seed to be used here, so that you will be able to get better yields. That's something. On the other hand, you have what is known as this output. Once it gets the harvesting, it is basically from the harvest. This takes care about right from sowing the seed to the harvest, and then to the it will be connected to what is known as market, right? So that is called as supply chain. So this whole thing is called as smart farming, right? So this is possible only because of this introduction of this this mechatronics system there, right? So that's what you find it quite interesting, especially when you go to this. There is a lot of scope for this smart irrigation system, and then intelligent highways. This is what is basically required for India, because now you see that urbanization is increasing. People coming from villages are getting into cities for their livelihood, because they are in search of opportunities. So in that case, there is going to be a very road, especially on the roads, right? So people should take care of this. Also, the smart transport system. Of course, the smart transportation which you see on the road as of now is electric vehicles there, right? So the combination of all these things, all smarts, you put all the smarts and make all the whatever the activities you got put as a prefix is smart, right? If you can take care of that, then whole of your city becomes smart cities, right? So the resources have to be managed properly there, right? Less hazardous, minimum transportation, right? And the use of oil, the hydrocarbon oil, has to be reduced there with the introduction of new technology, right? So that is where you find that applications are quite wide, right? So this is a video, I can't show it, you can see it somewhere there. Anti-lock braking system there, even this air brake also there. You can take a look little later there. So these are the combination. When you get that mechanical into electronics, so how you get this, and computer design, all those things will give rise to mechatronics. You can see that this is where you find the mechatronics here, from where it is all from my combination of your mechanical, computer, control, electronics. Control here means basically it is connected to the electrical engineering. So don't feel if anybody is from electrical background, so why you not put this? Control engineering is it is an offshoot of electrical engineering only. But here, because control control engineering is very important for the mechatronics, that's why control engineering has been taken here. But otherwise, it defines the presence of electrical engineering there, right? That's what you see it here. And these are the things that's what I already shown you this, right? Then there are quite a few merits of mechatronics there. So one is the integration is at a higher level, as I told you earlier. That means if you can make it, then it is really higher level there, so that you will be able to get the best. Then functionality will definitely increase, and the design is much better. The more use of electronics and software, you will be using definitely the electronics. Otherwise, it cannot be called as a mechatronics here. Then you'll be using definitely the softwares for programming there. Then artificial intelligence and intelligent process control, that is where you come into. So when you have this fuzzy logic, neural network, all these things, especially neural network is one which has to be taken care. Neural network is one where once you start using this means it is training of the brain. So every time you learn something, and that will be used for the next decision making. So that's where your artificial neural network will come into picture there. Then assume responsibility for a process and operation with little interference of. This is where mechatronics plays a vital role. So there will not be any interference of individuals. Human interference is negligible there. Then multi-sensory and programs environment. You will be using multi-sensors so that you will be able to take care of every event there. Then high reliability and safety, and of course precision also there. The products produced are cost effective and very good quality, because you already taken care of the cost of these products, because only to achieve a better quality, so you have used various things there. So obviously the products so obtained, they will be cost effective and very good quality there, because you will be able to produce large number of goods in short notice and with better quality there. Then high degree of flexibility, you can make the changes, because whatever the requirement you make, you can go back to the design there, make changes according to the requirement and change it. That is the flexibility there. Then greater extent of machine utilization, yeah, because earlier machines were used only for one purpose. Now you can make them intelligent. They become intelligent machine there, so that you can use them to the larger extent there. Then productivity definitely will come. Then high life expected by proper maintenance. Mechatronics, if you maintain properly, you will have the better maintenance there. Then integration of sensors is very, in a complex system, reduces capital expenses, because here now you don't have to, although there are a number of sensors there, you don't have to use all the sensors. In that case, a proper control and use of these integration of these sensors will reduce the capital expenses there. Then the few demerits are one is the cost is high. Obviously, if you look at the integration of various technology, so you need experts. So experts come with a price tag. So they are obviously cost effective. They are very expensive initially there, but this initial cost will be overweighed by the results what you are going to expect there. Then it is a complicated design. Definitely it's not a straight design. It is a complicated one, and specialist are required. And maintenance definitely is quite complex, because even if you take the case of your IC engine, now it is simple. But if you take the case of a maintenance of an electric vehicle, this is complex, because we are not used to that, right? So similarly, mechatronics is quite complex there. Then it is replacement is difficult, and difficult to change old system to new system. So one is you can, whatever you have done it is done. So the old one cannot be changed to a new system there. Only thing is you have to redo it again. See that a particular mechatronics system is useful for a particular application there. Then the knowledge of different disciplines for design and implementation is a mandatory. It is, without that you cannot do that, first of all. And the specific problem of various systems will have to be addressed separately and properly. So it is not a one-stop solution, right? You'll not be able to get that one-stop solution. You will have to address it separately depending upon the intensity of problem that you have got there. Okay. So that's how much time I got? Somebody tell me.
So time up, sir.
Time up.
Sir, we are about to continue.
Okay, then go over. Just I'll take 2-3 minutes there. And as far as mechatronics and automation, then automation is one thing. Basically, it will be able to create the application of technologies for basically producing the goods and services with the minimum intervention of human being, so that you'll be able to produce the goods at a very cost effective and a qualitative manner there. And that's what basically your automation there. And these are the various things you got. The last but one I have to say here is that 1 minute. These are the mechatronics revelation there. Okay, all right. Okay, 1 minute. Okay, also these are right. Basic difference I need to look at here, especially this is what I want to talk about. See, the opportunities for mechatronics engineers, of course, including automation engineers. One is they can work as a robotic engineer. Especially these courses are available in different at the MS level, I mean at postgrad level as well as at the graduate level, right? So you can be a robotics engineer, you can be an automation engineer, there control system design engineer, then electronics design engineer you can got if you are really not from the, if you are only a mechatronics engineer, then you'll be able to see that. Then you can be an instrumentation engineer there, or a software engineer, or advanced manufacturing and robotic there. And responsibilities will be obviously for intelligent equipment development, products and build types, and test new equipment and install new equipment there, right? So this is the salary package one can expect per year as of now globally there, right? So it will start from somewhere 51,000 per year, a dollar in terms of the dollar here, go up to $64,000 here, right? And as far as the mechatronics is concerned there, you can do everything what you want, especially if you are a mechatronics engineer with a degree, right, in the on your hand there. So you can do whatever you want because you have the synergistic combination of our integration of various disciplines on your hand. So you can really make really wonders. Okay, that's all I want to say. Thank you, Amish. Thanks a lot.
Thank you, sir. Suresh, sir.
Friends, any questions can post in the chat box.
Yeah, sure.
Or they can unmute themselves and directly ask the questions. Yes, Srinivas Chalapati, sir, you can ask the question, sir.
Sir, good evening, sir.
Yeah, good evening.
Chalapati from Andhra University.
Yeah, please.
Sir, the robot that you have shown, that the Coco robot which played the
table tennis, yeah.
Sir, there not only the sensors and all, I think even artificial intelligence is also played a major role because it has to calculate which one, what it has to do next, like that.
Definitely. See, as far as the video what I show, it is only a small thing which I talked about, connecting with the mechatronics, but that is not the end of it. It has got so many things, so many sensors are there. In addition to sensors, there are actuators, even the vision, right?
Yes, sir.
And the integration of software. Various disciplines have come into
Yes.
Various disciplines have gone into that so that they'll be able to produce such a world-class robot. It is not merely the part of the mechatronics which I talked about. It's only a part of that which has been used there. But beyond that, there are many more things have been used there. Because the way especially the robot maneuvers itself, its hands, controls.
Yes, sir,
So
yes,
that is what is very, very important there. So it is all about the control and various disciplines which have been interfaced there. Thank you.
So for a robot to work like that, the mechatronics, the actuators, the sensors, the vision, and the AI, the program controllers, everything need to work.
Everything. It is not
Yes.
whatever I mentioned is only mechatronic part of it, but otherwise what you have mentioned it is basically the artificial intelligence, because it has to take care of that. Artificial intelligence will be able to see, just like in the case of your Google, when you type something today, tomorrow you'll be able to see the same thing is appearing. It knows what are looking for, accordingly that will appear.
Yes, sir. Yes, sir.
Exactly the same thing. It will basically learns from the mistakes or learns from the opponents also. For example, somebody like say, take the case of just forgot it. Yeah, it is something like ANN, especially artificial neural network there. So it basically learns from the mistakes it has done or whatever it has done, it will start developing over that, and that will be able to give you a good idea about how best it will be able to perform in the future there. Okay,
Yes.
thank you very much.
Thank you. Thank you, sir.
Thanks a lot.
Participant, any more questions? Okay. Now we are at the
Madhavan
end
sir,
of the talk.
Madhavan sir, I think he's asking something.
Okay.
Dr. Madhavan sir, I think you have posted some question in
Yeah,
chat
I think.
box.
Can you read that, please?
Okay, sir. Concerned with system orientation, not with domain orientation.
Yeah. I didn't get you. Can you please?
Sir, the
repeat?
question is posted like this: concerned with the system orientation, not with the domain orientation.
Uh-huh.
Sir, Madhavan sir, you can unmute yourself and ask the question clearly.
May I understand with mechatronics system as a system orientation, not as a domain orientation? Is it, sir?
It is, see, it is basically the combination of both. It is not really, you cannot say that it is not a domain orientation. Domain orientation comes from every discipline which you are considering here. System oriented, based on the system which you are going to devise, it will have the synergistic combination of the domain orientation. Without the domain orientation, you will not be able to get that the system designing there.
Thank you, sir. Thank you.
Okay.
Any more questions, participants? Okay, now we are at the end of the talk. On behalf of the management, principal, and staff of CIT, I express my heartfelt gratitude to the speaker, Dr. Ramesha SP, for engaging the session and giving insight on the role of mechatronics in industry automation. Thank you for your valuable time and patience, sir.
Thank you very much. Thanks a lot. I must mention here that I'm thankful to the your CIT and the principal of the CIT, Dr. M. Basaraj, who happens to be my the long ago, couple of years ago. I think I should say 2 decades ago we were together, only for a short duration. Later on, we are separated, and this platform has brought us back together to see each other and share our ideas. Thank you very much.
Thank you, sir. Participants, now we are going into the validatory functions. I request all participants to be on the line. Feedback will be posted after the validatory function. Now I would like to call our beloved HOD to give welcome speech for validatory function.
A very good morning to one and all present here. Honorable President of Kodava Education Society, Sri C.P. Belliyappa, Vice President, Dr. M.C. Karyappa, Secretary, Sri Rakesh Povaya CP, Board of Directors of Kodava Education Society, our beloved Principal, Dr. M. Basavaraj, resource persons, all the participants and members of organizing committee. At the very outset, I would like to express my sincere gratitude to all the stakeholders who have directly or indirectly helped us to successfully complete the faculty development program. On behalf of Department of Mechanical Engineering, Coog Institute of Technology, I consider it a privilege to welcome Sri Rakesh Povaya CP, Secretary, Kodava Education Society, for today's validatory function. Sir, your presence is indeed a source of motivation. We look forward to your validatory address today. We welcome you, sir.
Thank you. Thank you so much.
We have Dr. Ramesh SP, Associate Professor, Department of Mechanical Engineering, Presidency University, Bangalore, who was the resource person for the concluded session. Welcome you, sir.
Thank you very much.
I would like to welcome our beloved principal, Dr. M. Baswaraj, who is a source of inspiration for all of us. A warm welcome to you, sir.
Thank you, sir. Thank you.
I would like to extend warm welcome to all the resource persons. We are certainly grateful to you all for courteously and gladly accepting our invitation to share your knowledge. Welcome you all. I am delighted to welcome all the distinguished participants. This program could not have been made possible without you. Welcome you all. I would like to extend a very warm welcome to all the heads of the department, faculties, staff members, and students. I once again welcome you all for today's valedictory ceremony. Thank you one and all.
Thank you, sir. Now I would like to call conveyor of FTP program, Mr. Gnanesh sir, to give a brief report.
Thank you, Suresh sir. And very good evening to one and all. Every journey has a beginning and an end, but learning never ends. Finally, we are about to conclude this 6-day faculty development program on recent developments in mechanical engineering. This faculty development program is organized with an aim to give insight into the happenings in the various areas of mechanical engineering and to enrich the knowledge of faculties and research scholars through interaction with eminent personalities from the academics and industry, and thus enhancing the academic and intellectual environment in the institutions. I am confident that outcome of this program will fulfill its purpose. Department of Mechanical Engineering, Coorg Institute of Technology organized 6-day faculty development program and recent developments in mechanical engineering by inviting esteemed professors and industry personals from various organizations to give a talk on diverse field of mechanical engineering. On the start of this event, we have received overwhelming responses from the participants across the country, and around 360 members participated in the event over Zoom meeting and YouTube platforms. The 6-day faculty development program began with the inaugural ceremony in the gracious presence of Sri C.P. Belliyappa, President, Kodava Education Society, and Chief Guest Dr. C. Venkatramana Reddy, Vice Chancellor, KK University, Nalanda, Bihar, and Dr. M. Baswaraj, Principal, CIT, on 21st June 2021 at 9:30 a.m. So during the inaugural ceremony, Sri C.P. Belliyappa delivered the presidential speech and offered his best wishes for the accomplishment of this program. Dr. C. Venkatramana Reddy delivered the keynote address focused on past, present, and future of mechanical engineering in the first session. In his address, he emphasized on improvement of skill and knowledge to meet the challenges in the present scenario. The resource persons for the second session of day 1 was Dr. G.C. Mohan Kumar, Professor, Department of Mechanical Engineering, National Institute of Technology, Surathkal. Dr. G.C. Mohan Kumar delivered the talk on topic Mechanical Engineering Application in Biomedical Engineering. He broadly explained the scope of mechanical engineering in design of equipment and devices such as artificial internal organs like artificial hearts and knee joints, and replacement of other body parts, and machines for diagnosing medical problems. And day 1 third session is on the topic design of experiments using Taguchi optimization technique, presented by Dr. Veerbhadrappa Algur, who is a professor in the Department of Mechanical Engineering in the Rao Bahadur Y. Mahabaleshwarappa Engineering College, Ballari. Dr. Veerbhadrappa Algur elaborately presented the methods of Taguchi optimization technique for solving research problems. And on second day, the session 2 is addressed by Dr. Subramania Swamy, who is a professor in the Department of Mechanical Engineering, Global Academy of Technology, Bangalore, shared his knowledge on the topic Advanced Materials for Building Precision Machine Tools. His presentation focused on type of advanced materials, properties, and their applications in modern machine tools. Session 2, on day 2, the session 2 is delivered by Dr. Devaraj, who is the head of research and development in the School of Mechanical Engineering, Reva University, delivered the talk on processing of light structural alloys through different casting routes and its characterization using different techniques. He has given greater insight into the types of structural alloys, different casting routes for production of light structural alloys, and methods of testing for characterization of these alloys. On day 3, for session 1, the resource person was Dr. H. Naganagowda, who is a former director, National Training Center for Solar Technology, Karnataka Power Corporation Limited, Bangalore. He delivered a talk on renewable energy and energy conservation for sustainable development. Dr. H. Naganagowda stressed on the importance of solar energy for the future as a major source of energy. Also emphasized on the various projects undergoing in India and all over the world for harvesting of renewable energy sources. And also he shared his ideas about getting the funds for carrying out the projects on renewable energy sources. On day 3, the second session was engaged by Dr. Nagaraj Kori, who is a professor in the Department of Mechanical Engineering, Rahubadur Y. Mahabaleshwarappa Engineering College, Ballari, delivered the talk on his research work, Passive Cooling Methods, a study on thermal behavior of opaque ventilated facets. So he focused his presentation on the different materials and different types of facets used for building for passive cooling of the buildings. On day 4, the session 1 is delivered by Dr. S. Kumarappa, who is a professor in the Department of Mechanical Engineering, Bapuji Institute of Engineering and Technology, Davanagere, as he delivered a talk on application of machine intelligence in mechanical engineering. So he has stressed on the application of machine intelligence in autonomous vehicles. Also, he has given an idea about different levels of automobile vehicles like level 1, level 2, and level 3 autonomous vehicles. How this machine intelligence is playing a role in development of these kind of vehicles and also different machines. And the second session is engaged by Dr. Vijay Kumar, who is an associate professor in the School of Mechanical Engineering, Reva University, Bangalore. So he delivered a talk on processing, characterization, and application of carbon-based nanomaterials, especially carbon nanotubes and graphene. So he has given an insight for the materials, rare materials like carbon nanotubes and graphene, what are the methods for synthesis of these materials, and what are the techniques or methods used for studying the characterization, and what are the practical application of these materials. And therefore, the first session is engaged by Dr. M.M. Rajat Hegde, who is a professor in the Department of Mechanical Engineering, Jawaharlal Nehru National College of Engineering, Shivamogga. The topic on which he has delivered his talk is on synthesis and characterization of nanoalloys. So he has given insight into what is nanoalloys, different types of nanoalloys and the synthesis methods, and studying its characteristics. And the second session of day 4 is engaged by Dr. Manjunath C., Professor, Department of Mechanical Engineering, Acharya Institute of Technology, Bengaluru. So he's presented a talk on his research work about conversion of biomass waste and its application in direct injection diesel engine. He elaborated how to utilize the bio waste into a useful energy. On the day 6, The first session is delivered by Dr. Suresh Bhimbappa, who is a professor in the Department of Mechanical Engineering, National Institute of Technology. He is delivered a talk on 3D printing for polymeric composite bearings. So he emphasized on the 3D printing method for manufacture of a bearing using 3D printing technique for different types of composite, by using different types of composite materials. And the second session is engaged by Dr. Ranjit M, who is assistant professor in the Department of Mechanical Engineering, NITK, Surathkal, Karnataka. He is delivered a talk on computational modeling of fluid structure interaction problems. So he has given an how the computational modeling is applied for the fluid flow analysis in solving the fluid flow problems. And the last session of the day 6 is presented by Dr. SP Ramesh, Dr. Ramesh SP, Associate Professor in the Department of Mechanical Engineering, Presidency University, Bangalore. He delivered a talk on the topic role of mechatronics in industry. So he has given an insight into what is mechatronics and how this mechatronics is playing an important role in making everything automated, and how everyday life is changed with this automation. So CIT, Department of Mechanical Engineering, CIT wholeheartedly thank all the resource person for sharing their knowledge with all of us. Also, Department of Mechanical Engineering, Coorg Institute of Technology also appreciates the participation and involvement of all our participants who has spared their valuable time in experiencing the knowledge shared by our resource person. I believe by participating in this session, we all have gained useful knowledge, and this will be useful in the future to carry out the research work. We also welcome valuable feedback for improvement and future planning of such a programs. And we are looking forward for your active participation in the coming days and hoping for the great responses. I thank each and everyone for your support and to take part in this program. And lastly, but not the least, a special thanks to our respected management and our beloved principal and my dear colleagues for their wholehearted support in making this event a very successful one. Thank you, one and all.
Thank you, Ganesh sir. Now I would like to call our beloved secretary, Shri C.P. Puvaya, to address participants.
Okay. Am I audible? Am I audible?
It's audible.
Yes, sir, you are audible.
Yes, sir, you're audible.
Okay. Greetings and good evening. Respected Dr. Ramesh SP, Associate Professor, Presidency University. I could get 5 minutes of your talk because I had a lot of network issues. I don't know, in the background, you must have heard me screaming at my son because he was trying to fix it. Dear Principal, HOD, Professor Timaya, all the faculty of CIT, and all the participants, and not to forget all the speakers of these last 6 days. I thank all of you for enlightening our faculty and other participants. The faculty development program on emerging trends and development in mechanical engineering, I would really like to congratulate our HOD, Professor Timaya, along with his dedicated team of mechanical teaching as well as non-teaching faculty. Thanks for bringing up this topic. Emerging trends is always good to know. Congratulations to our principal also. I request all of you to continue doing this in the times of pandemic. Let's go virtual. We have to put CIT with the best engineering colleges in Karnataka and in India. I would also like to please tell our faculty as well as all the participants, in this last 6 days, you have learned quite a lot. Please do not keep it inside. Please share your knowledge with your colleagues, and our dear students, which will help them immensely. Because honestly, I feel if we follow the curriculum, we will be behind. We have to go with the latest trends. And I should thank all the eminent speakers over the last 6 days for updating all the participants with this program. Dr. S.P. Ramesha spoke about mechatronics today. My knowledge of mechatronics is, I think it's the integration of especially mechanical, electronics, and computers. Anybody can correct me if I'm wrong during my this talk. Very interesting thing. This morning, I happened to visit one of my fellow farmers' estate. So we had this drone. This drone had a payload of, I think, 12 kgs. I'm not sure, but I think about 10 to 12 liters of pesticide it could carry. They were actually experimenting on the areca plantations, spraying of kolenashak to your areca plants to save your harvest from rot because of monsoon. But the only thing I could see was we had this drone. He had a transmitter. The limitation is, in Coorg, we have a lot of trees. So this technology, it is there through artificial intelligence. I know these DJI drones have anti-colliding mechanisms, where in case the pilot who's flying it makes a mistake, it will not collide. It will not collide with the trees. So there are small improvements. I think once artificial intelligence comes in, and when you can have autonomous drones without any human interference, I think that's the day which it will benefit. I'm talking from the farmer's point of view. I know, especially in the military areas, it's very, very, very important now. The point what I'm trying to make is, yes, we have a curriculum where we have mechanical as a different branch, computer science as another branch, and electronics another branch. But in reality, if these three streams are civil, I don't know how to connect civil to all these three departments. But without the three, in today's world, nothing is possible. We need it's all interlinked. So any research that happens in the future, I think it has to be the coming together of the three departments. Professor Timaya, do you agree with me on that?
Sir, definitely.
Okay, fine. What I want to say is, yes, our mechanical department, times of pandemic, no projects happening, nothing happening. I request the mechanical department to get in touch with electronics and computer science and come out with student projects which will be recognized globally. I'm saying globally because in this globalized world, we can compete with the best anywhere in the world. In the past, say you go back 20 years, without the advent of technology, we could not compete. I think the American universities especially had a bigger advantage over us because they were a much developed nation. But today I'll say India is the best. So I congratulate you. I request all of you to do your best for the college. Please keep the flag flying high. Thank you so much.
Thank you, sir.
Thank you for your wonderful words, sir. We hope we will implement these things in our future, sir. Thank you. Now I would like to call our beloved principal to give word of thanks.
Thank you, Professor Suresh. So very good evening to all. Our Honorable President, Mr. C.P. Beliappa, sir, Dr. M.C. Karyappa, sir, and today's chief guest, our Honorable Secretary, Mr. C.P. Rakesh Puyava, sir, the respected directors of Kodava Education Society, today's speaker, Dr. S.P. Ramesh, all my department HODs, my dear colleagues, the participants from the various colleges, ladies and gentlemen. Today we are coming to the end of a 6 days national faculty development program on recent developments in mechanical engineering organized by the Mechanical Engineering Department. At this juncture, I thank the Professor Timai AG, the HOD and the convener of this FTP program, and the Professor Ganesh, the coordinator of this FTPP, and all the staff members of the Mechanical Engineering Department for organizing this wonderful FTP program. It's a great pride and honor to thank from the bottom of my heart our management, the President, Vice President, and Secretary, sirs, and all the directors of the Cordova Education Society for a constant support and encouraging for conducting this FDP program on the behalf of the Mechanical Engineering Department on my personal behalf. Thanks to all, sir. I wholeheartedly thank all the resource persons, to name a few. Dr. C. Venkatramana Reddy, the Vice Chancellor of Nalanda University, Bihar. Dr. Mohan Kumar, the Professor from NITK Surathkal. Dr. Suresh B. NI Mysore, and others who are great academicians and researchers from the reputed universities and institutions for accepting our invitation as a resource person for this FDP program. I hope this FDP could have helped to enhance the teaching and other skills of the faculty. Without your support and your active participation, this FDP program would have not become a great success. I thank all the participants of the various institutions actively participating in this FDP program. It was found that there was a good interactive sessions in all these 6 days. I hope the most of the teaching fraternity who are pursuing and guiding research work could definitely help this FDP program for guiding and doing the research works. Once this pandemic situation comes to a normal, I appeal all the participants from the various organizations to have a long-term relations, the knowledge and technology transfer in the physical mode. I welcome all the participants to visit once to this beautiful place, Kurk. And finally, I thank everyone who have helped directly and indirectly to make this FDP program a grand success. Information to the participants: the certificates will be issued to your email IDs. With this, we're coming to the end of this FDP program, appealing all to take care and be safe. Thank you, one and all.
Thank you, sir. Now I would like to call upon participants, those who want to speak and give the feedback on the 6 days FDP program can give.
Well, this is Dr. Ramesh. Can I have a quick word?
Please, sir.
Yes, sir. Yes, sir.
Yeah. In fact, at the outset, I'm really impressed by Mr. Rakesh Povaya. I never thought that a person can go so deep into that in only few slides, because he said he missed many of my previous slides, but I happened to see few slides. But your experience, especially in the morning, what you shared with us, that's really wonderful. That's really inspire anybody to take this mechatronics to the next level. But I urge, because your Kurk Institute is in such a holy place, it's such a good environment, lush green environment there. I think you people should be able to try to take this mechatronics as one of the disciplines in your mechanical engineering, because mechanical engineering, as you know, it is taking a backseat for the simple reason what you already mentioned in the last few minutes, that the rest of the department should come together to make a difference. That is what I think you can take an initiative to make the difference by bringing in this mechatronics as one of the branches. Because nowadays, I can see that a lot of things are happening as far as mechatronic things are concerned. Because students are interested in different disciplines. And unfortunately, students from mechanical cannot go to other departments and learn because of the academic pressure. If that academic pressure is eased out by bringing other disciplines into the mechanical, calling it as mechatronics, that will be a great job. Correct me if I'm wrong.
Thank you. Thank you for the kind words. We will definitely look at it. Thank you so much.
Thanks a lot. Thanks for sharing with me.
Thank you, sir. Any other participants who would like to speak?
I request any of the participants to share your experience of this 6-day faculty development program so that it will be helpful for us in future to organize such kind of programs in a larger scale.
Good evening, sir.
Good evening, sir.
Myself, Dr. Vasant Kumar from BIT Mangalore.
Yes, sir. Yes, sir. Go ahead.
First of all, I would like to congratulate team coordinator, HOD, principal, and management for the great success of this FTP program. And I was attended almost all the sections since first day. So it was very informative and interesting. So thank you for giving opportunity to participate in this FTP program. Thank you, sir.
Thank you so much.
It's our pleasure.
Okay, thank you so much, sir. Any other participants who would like to speak?
Venkatesh Kulkarni, sir. So you were there for all the sessions.
Hello, sir. I am myself,
Hello.
Srikant Patil.
Hello.
Yes, yes, sir. Yes, sir.
Yes, sir.
Yes, sir. This I have attended almost all the sessions. Some too I have missed because of I have taken the classes. So it was a good content. I have working as assistant professor in aeronautical department. Basically, my degree is from mechanical. So it was very useful FDP, sir. So I am looking forward to. I am looking same in the offline also. It was overall it is very good conduction and presentation from the organizers and session chairs also. They are from various good institutes. We have learned from this FTPs. Thank you, sir. Thank you so much for your efforts and all the organization.
Thank you,
Thank you,
sir.
sir.
Thank you so much.
Thank you, sir. I would like to thank all participants who have joined the live session. I request all the participants to fill feedback for the session shared in the chat box. A e-certificate of the FTP will be shared to the registered email ID. Thank you and signing off.
Thank you, sir.
Thank you, sir.
Thanks to all the participants once again.
Yes, sir. Thank you, sir.
So kindly fill the feedback form. You will get the certificates by tomorrow. Today and tomorrow. In 2 days, you will get it.
Okay, sir.
Hello.
Yes, sir. Yes, sir.
You just ask me about the feedback for this FDP. Just I wanted to tell my feedback.
Yes, sir. Yes, sir.
And he told his opinion. Just I want to comment on the feedback. even though it is a new institute, many people would have seen or would not have heard about the Cook Institute. But anyhow, you have made a good attempt. And in fact, we expect the same to be conducted offline so that they can interact with each resource person. But what I felt, many of them, they log in, but whether they are participated or not, we don't know. But that is how it goes in online mode. That is my request is you can conduct similar type, especially theming it a specific name, not generic name like mechanical engineering. Generic name like mechanical engineering. If you put name like advances in mechatronics engineering, advances in thermal engineering, or advances in manufacturing engineering or design engineering, that will give some more strength to participants, not necessarily to separate it from mainstream mechanical engineering. But the idea is it strengthen. Many times, many people, even though you have covered a lot of good things, new advances, but when people heard about mechanical engineering in general, many would not come forward to participate because it is general means they again go into the simple things, basic things. That way, I expect you, if you are organizing, you give some theme, maybe energy conservation or whatever Rakesh Puya sir told. That way, you can also call it as a design, selection, optimization of some mechatronic system. That way, if you give, that will give strength to institute also and even to resource person. That is my request from my end. Anyhow, it went very thoroughly. And feedback with respect to feedback link. Many people are asking about feedback link without they are attending it, it seems. But I feel unless you attend it and you cannot write feedback, but instead, if you take session wise, immediately you can send a link. Even if you post it to the WhatsApp group, they will comment. I attended similar type of FDP where they come up with some quiz, whether he has attended thoroughly this FDP. They used to pose some questions where participant used to answer maybe 10 questions. That's all. That way, if you do it, it gives some attentiveness for participants, and also your effort will be more fruitful because you have put more effort to conduct 6 days. Instead, you can coin 1 week FDP. That is my suggestion so that it can be improved further. I have never heard a 6 day FDP. Either it is 5 day or 1 week FDP. But 1 week, since you work for 6 working days, it can be called it as a 1 week. I request you to give certificate as a 1 week FDP. That will also boost anybody's prospects. Even for college, if they conduct it, people will also like to come. It is strengthen institute in getting good scores in NAC and even in NBA. Similar type you can take up for NAC accreditation and even for NBA accreditation process.
Thank you, sir. Points are noted down. Thank you for your suggestions. We are going to improve all those things in the coming.
By the way, I forgot to tell my introduction. Myself, Dr. Venkatesham Kulkarni, working as a professor in the Department of Mechanical Engineering, Vishwesvaraya Technological University, Belagavi.
So Dr. Venkatesh, sir.
Yeah, tell me,
very
sir.
thankful for your kind information, sir. Okay, we'll take in the right spirit.
Okay,
so this, as you know that this Core Institute of Technology is a 22 years old college.
Yes, sir.
And of course, we are conducted for the, as you said, for the NAC point and NBA point of view, we conducted instead of 1 week. So we made a 6 days,
yes,
particularly the reason of getting the good marks.
Yes, yes.
And
yes.
one more thing is, instead of, okay, we thought of having 2 days or 3 days workshop.
No, that will not
especially
work.
the specialized course like okay, that's only for the mechanical stream or the design stream, thermal stream.
Yeah.
Okay, production stream. So we'll have 2 to 3 days in a workshop or 2 to 3 days in a faculty development.
If you want to do morning theory session will be there, afternoon somewhat interaction type or hands-on type That is what these IITs they are doing. Even I attended a week, even 2 weeks programs in IITs also.
So this is because of the pandemic, we conducted this in the online.
No problem, sir. These 2 years, everybody is conducting online. That is not an issue. But for improvement, even for everybody's benefit, I just suggested.
No.
It is my personal opinion.
We will take your suggestions 100%, and in future we'll try to have a more number of these type of programs, preferably on the offline mode.
Okay. Thank you, sir.
Thank you for your suggestion, sir.
Okay, thank you, sir.
Okay, sir. We'll wind up, sir.
Oh, please. Thank you.
Okay, no problem.
Thank you.
Thank you once again, everyone.
Thank you, sir. Sir, for organizing FTP, sir. Thank you, sir. Myself, Muturaj from Vidyavardhaka College of Engineering, Mysore, sir. Thank you.
Thank you, sir. Tamegowda, sir. Namaste.
Sorry, unmute ಮಾಡಕ್ಕೆ ಹೇಳ.
ಹೋಗ್ಬಿಟ್ರು.
Thank you, boss.
Thank you, Kumarappa, sir. Kumarappa, sir, is saying thank you in the chat box, sir.
Sir, thank you, sir. You have conducted a very good, sir, I'm audible, no, sir?
Yes, sir. Yes,
audible.
Okay, it's a very good, the program. I have attended almost all the programs. Means what you have conducted, all the sessions also. Nice, the presentation also. And one more thing is, means especially for the mechanical engineers, so we need to upgrade because that is a digital mechanical. We carried next, and that is a very digital mechanical engineering. That is a new era. So means we have to give the latest technology to our the students. Okay, that is a very important thing, sir. Okay, thank you very much, sir.
Thank you, Dr. Kumarappa, sir.
Thank you, sir. Thank you, sir. Okay, sir.
Tamegowda, sir, are you there?
Sir, ಹೇಳಿ ಸರ್.
ಹೇಳಿ ಸರ್. ನಿಮ್ಮ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್, ಐ ರಿಕ್ವೆಸ್ಟ್ ಯು ಟು ಶೇರ್ ಯುವರ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್, ಸರ್. ಕೇಳಿಸ್ತಿದೆಯಾ ಸರ್?
ಸರ್ ಕೇಳಿಸ್ತಾ ಇದೆ.
Please share your experience, Tamegowda, sir.
ಸರ್ ಕೇಳಿಸ್ತಿದೆಯಾ?
ಹಲೋ
ಸರ್, ನಿಮ್ದು ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? ನಾವು ಮಾತಾಡೋದು ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? So I think there is some network issue. Okay, sir. We'll wind up, sir. And thank you, Vasant, sir, for your message in the chat box.
I thank you very much, sir. Thank you for giving me the opportunity to attend this wonderful FTP program, and it was very informative, and the sessions were very informative from the speaker end. I thank everyone.
Thank you, sir. Thank you so much.
Thank you.
Okay, sir. Timay, sir, we'll end the meeting, sir.